So now we're on to part 2, okay? In this part, we are going to learn how to find the slope using this equation, okay? So the change in y, and remember, that's what this little triangle means. It's not triangle, this is change, okay? So you see that a lot in science and in math. Now this is the change in y over the change in x, okay? So we're gonna have to learn how to use this equation, okay? And we can use the rise over run to remember that when we talk about rise, we're talking about the y-coordinates, because the y-coordinates we often list on the vertical axis, and then the x-coordinates we often list on the horizontal axis. Okay, and remember, and we've kind of stated this, that you refer to your coordinate points as x and then your y values, okay? And you always got to put your brackets and your comma in between them. Okay, so finding slope using this equation. So determine 2 points that exist on the line. So here we can see we've determined 2 points on this line, for instance. Refer to one pair of the coordinate points as x1 and xy. Okay, so here they've said that whatever these coordinate points for B is x2 and x2 and y2, and this one will be x1 and y1. From there, you're simply just plugging it right into this equation, and you're going to be able to get the answer. Of course, remember that we can use our rise over run that we learned in our other video here, but we want to be able to do it algebraically because sometimes we're not given visuals, okay? And this is more useful as well because we can determine it using a more of a word problem. So some things to note, any points that exist on the line can be used. Again, as long as you know exactly what those coordinate points are, you can use whatever points you want. Remember to always be aware of the scale on your graph, okay? Because scale doesn't always just go up by 1, 2, 3. Sometimes it goes up by 2 and 4. And remember, be aware of your signs, okay? Lots of people don't be aware of their signs. Let's maybe do an example here. So to determine the slope using the following graph using 2 methods. So my first method, let's use the new equation I just created. So change in y over change in x, okay? So I'm going to use slope equals rise over run, which we can also write as change in y over change in x, and that'll be y2 minus y1 over x2 minus x1. So the first thing I'm going to do is I'm going to find a point that I can refer to as x2 and y2. Okay, so hang on, just make some room here. So x2 and y2. So what will my point I use? I'm not going to use like this point because then I'm guessing, okay? Let's possibly use, you want to find where there's some intersection points here. So if I look here, this is a pretty darn good point, okay? So I'm going to use this point here. Now, sometimes you have to determine what the heck the coordinate point is there, okay? And I'm going to show you how to do this. Now, if you can see that for some reason, they've decided to scale this where it's going up by 2.5. So this is 2.5, 2.5 plus 2.5 is 5. So you need to figure out what each individual tick is. So how the heck am I going to do that? Well, you always use your 0 and your first tick. Okay, in order to figure out how much each individual little tick is, what you're going to do is you're going to take your 0 to your first and recognize that this is a distance of 2.5. Okay, so each tick, that's what we're going to determine. So I'm going to do 2.5, and what are we dividing 2.5 by? Well, here we can see 2.5 is broken up in by 1, 2, 3, 4, 5, so into fifths. So I'm going to divide this number by 5. And that's going to show me what each tick is made up of. So 2.5 dividing 5, so it's made up by 0.5s. And we can check if that's correct. So here, this would be 0.5, this would be 1, this would be 1.5, this would be 2.0, and then we get 2.5, this would be 3, this would be 3.5, this would be 4, this would be 4.5. So look at that. It looks like we were, in fact, able to determine each tick pretty nicely there. Okay, so again, review, how do I do that? You always go to your first valued tick, okay? So 0, first value tick, 2.5, and then divide it by however many ticks it's broken up by. So this was broken up by 1, 2, 3, 4, 5. So divide it by 5. Okay, and you could do the same thing here. So in this case, our first value tick is 2. It's broken up by 1, 2, 3, 4. And 2 dividing 4, well, that gives us also 0.5. So each tick is 0.5. So 0.5, 1, 1.5, 2, so on and so forth. So we were able to figure out this point. This point, when x is 0, y is 4. So when x is 0, y is 4. So that's going to be my x2 and my y2. So this is going to be my x2 and my y2. So this will be 0 and 4. And I'm going to highlight that for everyone. And now let's determine my my y1 and my x2. So this will be, whoops, sorry about that. This will be my x1 and my y1. Okay, so let's find another point that goes in between the crosshairs. So right there, that's a pretty good point for us. Okay, and now recognize we need to know what our x value is here because it lines up with this x coordinate. Well, that will be 2.5, okay, because we just learned that it goes up by 0.5s on both. So my x1 will be 2.5, and then what's my y1? It's 2.5 as well. So this will be 2.5 for my x, and for my y, it's 2.5. So this will be x1 and y1. Now we can just use our formula now. So slope equals change in y over change in x, which is y2 minus y1 over x2 minus x1. And recognize that we have these values now. So simply, what is my y2? Well, I've made y2 my 4. So this will be 4 minus, now what's my y1? My y1 was 2.5. Dividing by my x2, x2 was 0, minus, and then x1 was 2.5. And then from there, we can solve. So this will be 4 minus 2.5. So that will give us, I believe, 1.5, but it's always good to check. So that is indeed 1.5. So 1.5 on the top. And then we're going to do 0 minus 2.5. And that's going to give us negative 2.5. And remember, the signs are really important. Okay, and let's see what that turns into. So 1.5 dividing negative 2.5. And that gives us negative 0.6. Now, something to note is you usually want to represent slope as actually a fraction, okay? So I'm going to represent this as a fraction. Now, how the heck do I do that? Well, hopefully you remember how to put decimals into fractions. 0.6, that is equal to, and remember, don't forget your negative, well, that would be 6 over 10, okay? And then we're going to divide by, and simplify this. So what are they both divisible by? They're both divisible by 2. So we will end up with negative 3 over 5. And we can check in our calculator. So negative 3 dividing 5 gives us negative 0.6. So now we have a rule here. So our slope is negative 3 over 5. And remember, we talked about this in our last video. That means that this negative can float. Usually it's easiest to put it on the top. Okay, so if I write it that way, I read this as every 3 units down, go 5 units right. Okay, because it's positive here, so that's 5 units right, and then 3 units down. So let's see if that works. Let's start at this point, and let's go 3 units down. So 1, 2, 3, and let's go 5 units right. Or sorry, that's not how it would work. We need to go 3 units down. This is 0.5 unit. So we want to go 3 units down. So 1, 2, 3, and then 5 units right. So 1, 2, 3, 4, 5. And would you look at that? We do end up at a point on our graph. So if we were to follow this rule, we go 3 units down, it's a little confusing. Sorry, that's a little confusing because it looks like we moved to the left a little. Let's make that a little bit more sensible. So we go 3 units down, which ends up right here. And then 5 units to the right. Five units right. And you do end up on a point. So that's how to use your equation. Now remember, if you were a visual person, you could also visually determine this as long as you keep your signs proper with the way we learned it here, using a more visual method. And that's great too. But the best part about this is now you can solve word problems, okay? So determine the slope of a line that goes through point P, negative 2, 1, and point G, 4 and 6. So if you wanted to take the time, you absolutely could draw a graph here. But we know that this is a straight line, so we can just simply use these points. These points exist on the line. Okay, so these points exist on our straight line. So all you need to do, and that's the best part about this equation, is you only need 2 points that are on our line. And then you just have to name them properly. So first of all, let's name y2 and x2. So I'm going to name those two this one. So P, this will be my x2, and this will be my y2. Okay. And then from there, I want to name my y1 and my x1. Well, that will have to be this point here and here. So that will be x1 and y1. And now we can simply plug in. So what was my y2? My y2 was positive 1, so this will be 1 minus what was my y1? My y1 was 6. So this will be 6. Divide. Now what was my x2? My x2 I put as negative 2. Subtract. And what was my x1? My x1 was 4. Okay, and if you aren't great at arithmetic, I would definitely use my calculator because you want the signs to be the correct signs. Okay, so here it'll be 1 minus 6, and that's going to give me negative 5. And then this guy, negative 2 minus 4, that's going to give me negative 6. And remember, you want to keep slope as a fraction, if at all possible. So what I'm going to do, I'm not going to divide these. I'm just going to leave it like that, and I'm going to just simplify. So 5 and 6 aren't divisible by same numbers, but our negatives here do cancel out. So this will end up becoming positive 5 over positive 6. So this now reads, remember it's rise over run, and they're positive, so it's 5 over 6. So this would be every 5 units up, go 6 units right. And there is our slope for this particular graph. Okay, let's see example 4. This one might be a little bit more tricky. So example 4, determine the slope of a line that goes through the x-axis at x equals 2 and the y-axis at y equals 5. So remember, if we want to think about this visually, we absolutely can. Okay, so remember, this is usually referred to as your x and this as your y. Now in this case, it says that this line goes through the x-axis at x equals 2. So when it's x equals 2, we actually go through that point. Okay, so what is this called? We know what this is called. This is known as your x-intercept. And remember, your x-intercept is when y equals 0. So if we actually wanted to list this coordinate point, it would be 2 and 0. And we can see that here. Our y value is 0, our x value is 2. So 2 and 0. It looks like our graph goes through the y-axis at y equals 5. So that's right here. And what is that? Well, that's your y-intercept. And remember, from our previous lessons, we know our y-intercept is when x equals 0. And you can see that visually here. When x is 0, y is 5. So this coordinate point would be 0 and 5. Now remember, the special thing about linear relations is you only need 2 points. And then you can actually graph this entire point. So if we create a straight line here, a little too slow, let's go boom. So our graph would look something like this, and then this would extend upwards on forever. So you actually have been able to create what this graph looks like because you only need 2 points, because it's just simply a straight line and then slope is constant. But we want to actually determine what slope is. And now recognize you could do this 2 different ways. You could use your equation, change in y over change in x equals y2 minus y1 over x2 minus x1, or you could determine it using visuals, rise over run. Let's do both quickly here. So now we have 2 coordinate points here and here, so we can actually simply use this equation. It's just a matter of determining what is my y2 and what is my x2, what is my y1, what is my x1. So let's name 0 and 5. Let's call that my x1 and my y1. And then that will make 2 and 0. Let's make that my x2 and my y2. Okay, and now it's simply plugging this in from here. So let's get all these colors the same. Okay, so now let's plug this into our formula. So I have decided that y2 will be 0, so this will be 0 minus y1, which is 5, dividing, and then my x2, which is 2, subtracting my x1, which is 0. And again, using your calculator is usually a solid idea, 0 minus 5, because negatives are really important in this. And then 2 minus 0 gives me positive 2. And then from there, you actually can't further simplify, right? 5 and 2 aren't divisible, and you only have 1 negative, so you're going to keep it. Now, this, remember, is our rise over our run. and our rise is negative, so this is every 5 units down, go 2 units positive right. So let's see if that works. Let's choose our point here, and it tells us to go 5 units down. So this is all the way at 5. So if we go to down 5 units, you're just going to end up at 0. And then you're going to go 2 units right. So that absolutely does work. Okay. So this is 5 units down. Got a few too many arrows going on there. And then this would be 2 units right. And it looks like we end up at our point happily. Recognize and remember that this sometimes it doesn't let me grab onto. There we go. Oh, sorry. But remember that this negative symbol can float on our fraction. So it can be listed here, it can be listed on the outside or down. Okay, so you will get the same answer as long as you do things properly. You could do this one visually as well. So we could ask ourselves, okay, how the heck am I going to get from this point to this point? Well, if I start at this point, I have to go 5 units up, 5 units up, and this is our rise. So this is the rise of positive 5. And then I have to go 2 units back or 2 units left. So I'm going to put a negative because it's left. 2 units left, and this is our run. So from here, well, my run is -2, so -2 on the bottom. My rise is 5 units up, so it's positive 5. And you get the same answer, right? Just remember that this can float, and usually it's easiest to put this just on the top, or you could simply put it in the middle, and then you can decide whether that negative is going to affect your numerator or your denominator. Okay, so hopefully things are making sense. This definitely is a lot of new stuff coming at you at once, so if you have any questions, please come ask. I would suggest opening up your textbook or any worksheets or assignments I've given you to try on your own and test your own understanding. Okay. I'm going to quickly go over positive and negative slopes. Now, something you've probably noticed is sometimes you have positive slope, sometimes you have negative slope, and you can see that even from the other examples. Like this would be a negative, this would be a positive slope, and hopefully you can see the patterns going on here. Anytime you have a positive slope, as you go to the right, you're increasing or going up. Anytime you have a negative slope, you're decreasing to the right. So here, this would be a positive slope because you're going to the right upwards. This is a negative slope because you're going down as you go to the right. This would be a line that's going upwards. This isn't exactly what the line looks like, but it would be going up because we know it's a positive slope. This is a negative slope because we're going down as you go to the right. So in the previous examples, we've seen positive and negative slopes. You may have seen a pattern such that a positive slope is a graph that has an upward trend as you go to the right. A negative slope is a graph that has a downward trend as you go to the right. So understand that the sign will be presented in the slope if you properly determine it. So as we can see here, we have a bunch of lines that all have positive slopes because they're going up as you go to the right. These all have negative slopes because you're going down as you go to the right. So that's something really important to understand, and it helps you in science, statistics, and economics, and obviously math. So that is how to find slope. So that was a ton on finding slope. The next little video I'm going to do is on what happens when you have a perfectly vertical line or a perfectly horizontal line. Okay, so I would definitely suggest practicing first finding slopes like this and then going and watching the next video. Other than that, have a good day.